The physics of living matter. Synthetic worms that move on their own. What if synthetic materials could move on their own, just like living organisms? Scientists at the University of Bristol have taken a major step toward making this a reality. They have developed lifelike, synthetic materials that can move independently, mimicking the behavior of worms. This breakthrough comes from a growing field of research into active matter, a new class of materials that possess the ability to move without any external force. Unlike traditional, inanimate materials like plastic or wood, active matter is made of elements that are constantly driven out of equilibrium by internal energy sources. This enables them to exhibit fascinating lifelike motion. In collaboration with researchers from Paris and Leiden, the University of Bristol team conducted experiments using microscopic particles known as Janus colloids. These particles, measuring just a millionth of a meter, were suspended in a liquid mixture and activated using a strong electric field. As the electric field was applied, the scattered colloid particles began to merge, forming worm-like structures. This resulted in a fully three-dimensional synthetic active matter system, something never observed before. Previous studies in this field focused on larger colloidal particles. However, by reducing their size to just a third, the researchers unlocked new three-dimensional movement patterns. These synthetic worms were found to self-assemble and move autonomously, resembling the motion of real-life organisms. First author of the study, Mr. Zichen Chao, explained that their findings allowed them to develop a theoretical framework to predict and control the movement of these synthetic worms based on their length. This could eventually lead to the design of self-moving materials, or even swarms of particles, that navigate toward specific targets. Professor Tanny Liverpool, a co-author of the study, believes that while real-world applications are still in their early stages, these findings could pave the way for revolutionary advancements. Imagine materials that can autonomously change shape, self-repair, or even seek out damaged tissue for medical treatment. At higher densities, the particles formed complex sheet-like and maze-like structures, indicating the potential for even more sophisticated applications. The research team is now conducting further experiments and theoretical modeling to explore these possibilities. The discovery of self-moving synthetic materials is just the beginning. Could we soon see artificial systems that behave just like living organisms? Only time will tell.